All right, welcome back. In this video, we're going to do some more practice with the code from Module 6. So in this video, we're going to work with a messy input file. And this is the messy input file. So hopefully it's kind of messy, and we're going to use some functions to format this information and create a neat output file. So let's take a look at the code and let's see what happens. So I got to go back here and download the code. So both of these using the end of file will work with this messy input file, and also formatting will work with the messy input file. So let's open our test project that we've already been working on. And I'm going to take the messy input file and put it into my project, which is located on my desktop here. So this is the messy input file that's not formatted. And there's code here that's going to format it. So let's get that code in my downloads. So I think it's called formatting. And let's take a look at this code. So this code is formatting code. So this code includes 4 different libraries: IOStream. I don't know if we're doing any input and output, so it doesn't really, well, yes, it's going to output onto the screen, so we do need to include IOStream. And then we have FStream, so this is for file input and file output. We have the C standard library. This is to exit in case it does not find the input file. And we're also including the class IOManip, which, the library IOManip, which includes functions to manipulate your output. I have a function here with preconditions. My precondition is that the file streams are messy and neat have been connected and opened. The post condition is that the numbers in the messy file have been corrected and display in both the neat file and on the screen. So I need to, since these are passed by reference, I need to have already have the variables for these, the objects for these files. So I have object in and object out that are declared in main. I open my input file called messy. If it doesn't open, my program will end. I open my output file called neat. If it doesn't open, my program will end. Assuming that my input file and my output file both open correctly, I will pass those objects by reference to my make neat function. The other 2 formal parameters are integers. So the integers, which right here in my function, I have an error in my function prototype because my function prototype should explain what these 2 integers do. So this is an example of missing part of the comments for the function prototype. Anyone who wants to use my program should be able to look at the function prototype and know exactly how to do it without having to know the implementation. That is the whole, that is a very big point that we covered in Module 5. And so you don't want to have to show your implementation to someone. You just want to show them your function declaration or function prototype and have enough information there so that they know how to use it and what to do with it. Now they do know that it needs 2 file streams, but I forgot to add what these 2 integers do. All right, so because I forgot to add what these 2 integers do, you would receive possibly some point deduction if this was assignment, but even bigger than that would be that you would not be doing a good job in demonstrating to the user how to use your function. Your function prototype should be complete with the precondition, the post condition, and everything they need to know to use it without having them to look at your implementation. But since I didn't add that, I'm going now down to look at the implementation. So there's two integers. The first one is the number. So that number is going to set the precision. Now I have the magic formula here. So if you want to know why I have two magic formulas here, one is because neat is the file, is the object of the output file. So that is going to setting the precision for the output file, and cout is going to print onto the screen. So I have two sets of the magic formula because I'm using two different objects. I'm using an object from OFStream and I'm using an object cout from OStream. So here is a this is a loop that's checking from the file to see if there is more data in the file, if there's another number to read into the file. And if there is, it's going to continue to get numbers from the file until all of the numbers have been read from the file. And the other integer here sets the field width. This is how many places the it should take up on the screen and in the file. So it's the field width I'm setting here in my example is I'm setting 5 decimal places with a field width of 12. So let's test it and see what happens. So if you see this, there's 5 decimal places and the field width is 12. 1, 5, 6, 7, 8, 9, 10, 11, 12. All right, so it took the messy, and we can go and look at the files here. So if we take a look on our desktop, we have our messy file that looked like that. And then we have the neat file that has used a little bit of manipulators to make all of the data neatly and in a column. So that's something that's very good to be able to do. All right, let's take a look at the next code example, which also uses that file, and that is using the end of file. So this is a little bit different. Where the other one had a loop, if you remember, let's take a look at it. This had a loop that is just checking to see if there's another number to read. It's reading the number and continuing to read a number and set the field width, and it's got the precision here. So it reads the number, prints it on the screen, prints it in the file, reads the next number, prints it on the screen, prints it on the file until there are no numbers left. This way is a little bit different. This is going to read from the file, but it's going to use a member function that's part of the IFStream in order to test to see if it has reached the end of the file. And as long as it has not reached the end of the file, then it's going to continue to get the numbers from the file and fix them and print them onto the screen and into the output file. So it has initialization for the loop, it has the test condition for the loop, and the update condition for the loop. The rest of the code is the same. So, and I think the input file, let's just call the output file neat2, just so we have a different output file and see if it still works. So it does the same thing. We use the same numbers. We could change this to be precision 3 and field width 10. So you can see you can change it. So this is a good to be able to know how to do this. This is just one of the few things that are part of the manipulator library. And the magic formula we will be using a lot in the class. I have one more code example in this module, so I'm going to go ahead and download that. This code example is not about file input, it's about using getLine. So let's take a look at it. All right, so this is mentioned in this chapter, but we will get in more detail in this when we get to strings and talk about the string class and C-style strings and stuff like that. But this is just a little example. We have input and output, so this is not using files. We have the string class, and we have C type, which uses the to upper and the to lower function. We have declared here a couple of characters. We have character 1, and then we have blank 1, which is a white space. Remember that white space is a character. If you used in your if you were in my intro to C class, we didn't really deal with white space very much. We did scanf with %C, and we put a white space between our quotation mark and our % that was saying ignore white space. CN will also automatically ignore white space. So if you want to have the user enter a blank character, the user will not be able to enter a blank character because CN ignores white space. Now, if you needed a blank character, you could use CN as an object, and this is a member function called get. So now you should be kind of curious, and you should want to type in CN dot and see some of the member functions that are available to you when using CN and Cout. So there's a lot of member functions available. We're only touching on some of the things that you can do in programming with CN and Cout, but these are just a few examples. So here you could get a character, and I already said that it will not work if you try to enter a blank character. So this is just a test to see what happens. Also, if you try to enter a book title that has more than one word in it, you will not be able to enter a book title with white space in it. So if you wanted to enter a book title called The Cat in the Hat that has a bunch of words with white space, it will not read it all in. So what you can do, if you wanted to enter a whole book title, you could use getLine. So you can test this code. I'm not going to test it. I want you guys to test it and try it and see what happens. There's also a question on your quiz about what happens with to upper if you print to upper onto the screen. And so I think I might do that. So let's say we have a character, and then we're going to see out the character that the user enters. So to upper, character that the user enters. This is a question on your quiz. The rest of it, I'm going to leave you guys to test, but I am going to answer your question on your quiz. So let's see what happens. So I'm going to enter. Hopefully this will compile. And then I'm going to enter a character. I'm going to enter the letter A. And if you look here, it did not print onto the screen the capital letter A. It printed onto the screen the numerical value of the capital letter A. So although this is a C thing to do, I do believe you can do this in C++. Let's see what happens. So I'm taking that numerical value of the uppercase letter A and hopefully casting it into a character to print onto the screen. Let's see what happens. All right, so there I was able to typecast. So the to upper function actually returns the ASCII or the numerical value of the uppercase, but you can, and this is not the C++ way to cast a variable, but since it works, this is a more straightforward way to cast that variable into a character. All right, so I hope that you guys will test this code and see what happens and come up with some questions and test yourself and try other things. It's very straightforward. There's some characters and some strings, and this is just an example. It is here on Canvas. This is called Chapter 6 Get Line. So download this. Also, you can test these other samples. And but the main thing that you should be getting out of Module 6 is the concept of an object and the ability for an object that has been declared from a class to use the dot operator to access the member variable functions. And we will be writing our own before you know it in this course.